those identities maybe, and plus that idea we started out with, right? Where you may have multiples of the input angle, and then so you solve for the multiple of the input angle, find all multiples, all values of the multiple that makes the equation true, and then divide by its coefficient, right? So, yeah, the mistake is to try to expand that sometimes. I mean, you can use double angle identities, but typically you want to avoid that if it's causing you trouble. Okay, so let's take a few of those. So now we're into 7.5, the last section in chapter 7, and this is how about 14? We got cosine theta minus sine theta equals 1. So what makes this different? Cosine theta minus sine theta equals 1. Well, for one thing, it's equal to 1, right? So it's not equal to 0. So we can't factor and use the zero product principle. Suppose we could subtract 1. Some of you may be tempted to multiply by cosine plus sine, get a difference of squares. You've got to be careful when you're multiplying by a variable quantity. You could be multiplying by 0 and introducing extraneous quantities, solutions, right? My colleague Matthews doesn't like this phrase, extraneous solutions, because they're not solutions at all. They're solutions to a different equation. Yeah. And so if you multiply by something that's 0, you get new solutions. Not solutions to the original equation. Whatever. So what can we do then? Is there an identity over there that applies to the difference of, can we write, how about the difference to product? Would that be a thing? Right, so do we have a difference to product with cosine and sine? Yeah. I'm sure we do. And I think that's going to be cosine, cosine. So if we have cosine alpha plus beta, let's say plus cosine alpha minus beta, is that? Maybe we should do this the other way around, right? And this is going to be cosine alpha cosine beta plus cosine alpha cosine beta, and sine alpha sine beta minus sine alpha sine beta. So the sine terms will cancel out and the cosine terms will double up. Oh, but that's the wrong one. Right? That's not the one we want. So let's go with sine sine. So if you have sine alpha plus beta, let's say minus sine alpha minus beta. I always have to reconstruct these things. So in this case, we'll get sine alpha cosine beta minus sine alpha cosine beta. And those will cancel out. And then you'll get cosine 2 cosine alpha sine beta. Does that help us with anything here? No, that's not good either. Sine alpha, cosine alpha sine beta. So, yeah. I guess we don't have one for difference of sine and cosine, huh? No, we don't. Oh dear, we are stuck, aren't we? Well, think about this.
One of them isn't square.
When you think about the unit circle, right? So if I have an angle alpha here, where this is cosine alpha and sine alpha, that's going to be this length minus that length, right? How could that ever be 1? about thinking about it this way? I've got the sine curve like this, and the cosine curve like that. Can the difference between those ever be one? Well, this is one, and this is negative one, right? Clearly they're not. Oh, so maybe somewhere in here, we could have a difference of one, so this is, you know, so maybe here and here? Yeah. In fact, right, there's a place when cosine is 0 and sine is 1. Where is that? That's at pi over 2, right? So up here, you're at 1, 0. Oh, well, that's the wrong way about, right? So how about here? 1, 0. So that the cosine is 1. Sorry, yeah, the cosine is 1. Oh, that's here, right? Cosine is 1 and the sine is 0. Yeah, so at 1, 0, that's true. And is there another place where it's true? Yeah. Well, back here again, but you're saying here, huh? Yeah, 3 pi over 2. I think that was Audrey's voice. Right? So sine is 0 and cosine is negative. Oh, but that'd be negative 1 minus 0. So that's not true either, right? So there's all these places where they differ by 1, but there's only one of them where cosine is bigger. Right? Your sine is bigger, your sine is bigger. Oh, here cosine is bigger. Oh, that's what you're saying. It's 3 pi over 2. So it's 3 pi over 2. Cosine is 0 and sine is negative 1. Right. So 0 minus negative 1 is 0, is 1. And 1 minus 0 is 1. So you can just kind of get this one by inspection. I don't know, is there like an analytical way of doing this? I suppose you could use the Pythagorean identity. Somehow, you know, say plus or minus 1 minus sine squared theta minus sine theta equals 1. Does that work? So I'm saying cosine is either the positive or negative square, depending on what quadrant you're in, right? So user discretion is advised. You have to, in order to know whether this is a plus or a minus, you have to know where theta is, right? Then you know the sign of cosine theta. Cosine is negative in the third and fourth quadrants, right? Oh, sorry, second and third quadrants. So,
That's what I was looking at right now.
okay, so this is plus or minus 1 minus sine theta is equal to 1 plus sine theta. Just add sine theta to both sides. Isolate the radical and square both sides. Let's see, now, so here now you could be getting an extraneous solution, as they say. So because the plus or minus goes away, you get 1 minus sine theta is equal to 1 plus 2 sine theta plus sine squared theta.
Is it 1 plus sine squared?
Are we good? I kind of know what the solutions are already, right? So I kind of figured them out. I haven't said what theta is, but I mean, it's kind of obvious. Either pi over 2 or 3 pi over 2, right? Here we got 0, negative 1, where 0 minus negative 1 is 0. Here we got 1, 0 here. Oh, 1, 0 here, right? So either here or here, which is 0 or 3 pi over 2. But let's see if that comes out here. So now if I switch the sides, add sine to both sides, I get this. And subtract 1 from both sides, I get that. Uh-oh, that looks terrible. Is that going to work?
Sounds decent.
Well, let's try it. So we factor out the sine, and we have sine theta plus 3 is the other factor, right? So either sine theta equals 0, or,
Sine theta plus 3 equals.
yeah, or sine theta equals negative 3.
Oh,
So where does sine theta equal negative 3? Nowhere, right. So you gotta throw that one out. Sine theta equals 0 at 0. Well, we found one of them. What happened to the other one? Yeah, we lost it.
Through
Uh,
that version.
Yeah. So this, substituting the radical and then isolating the radical and squaring both sides. Yeah, somehow, so where did it go wrong?
What would you get if you did it with substituting cosine?
Cosine, yeah, maybe try cosine. So we'd have then cosine theta minus, or plus, the square root of 1 minus cosine squared theta is equal to 1. So cosine theta is equal to plus or minus